Question 61. The development team has provided you with a Kubernetes deployment file. You have no infrastructure yet and need to deploy the application. What should you do? A. Use gcloud to create a Kubernetes cluster. Use Deployment Manager to create the deployment. B. Use gcloud to create a Kubernetes cluster. Use kubectl to create the deployment. C. Use kubectl to create a Kubernetes cluster. Use Deployment Manager to create the deployment. D. Use kubectl to create a Kubernetes cluster. Use kubectl to create the deployment. The best approach for deploying the application based on the provided Kubernetes deployment file is B. Use gcloud to create a Kubernetes cluster. Use kubectl to create the deployment. Explanation. Gcloud to create a Kubernetes cluster. The gcloud command line tool is used to create and manage Google Cloud resources. To deploy a Kubernetes application, you first need to set up a Kubernetes cluster on Google Kubernetes Engine, GKE, which is done using gcloud. Kubectl to create the deployment. Once the Kubernetes cluster is created, you use kubectl, the Kubernetes command line tool, to manage Kubernetes resources. Kubectl will interact with the Kubernetes cluster to apply the deployment configuration from the Kubernetes deployment file provided by the development team. Analysis of other options. A. Use gcloud to create a Kubernetes cluster. Use Deployment Manager to create the deployment. Deployment Manager is an infrastructure as code tool that is typically used to manage Google Cloud resources but is not directly used for Kubernetes deployments. It is not the best tool for applying Kubernetes-specific resources like deployments. C. Use kubectl to create a Kubernetes cluster. Use Deployment Manager to create the deployment. Kubectl is used to manage resources within an existing Kubernetes cluster, but it is not used to create the cluster itself. You should use gcloud to create the Kubernetes cluster, not kubectl. D. Use kubectl to create a Kubernetes cluster. Use kubectl to create the deployment. While kubectl is used to create the deployment, it does not support creating the Kubernetes cluster. Gcloud is needed to create the GKE cluster. Conclusion. B is the correct answer because it uses gcloud to create the Kubernetes cluster and kubectl to apply the Kubernetes deployment file, which is the standard method for deploying an application on GKE. Question 62. You need to evaluate your team readiness for a new GCP project. You must perform the evaluation and create a skills gap plan which incorporates the business goal of cost optimization. Your team has deployed to GCP projects successfully to date. What should you do? A. Allocate budget for team training. Set a deadline for the new GCP project. B. Allocate budget for team training. Create a roadmap for your team to achieve Google Cloud certification based on job role. C. Allocate budget to hire skilled external consultants. Set a deadline for the new GCP project. D. Allocate budget to hire skilled external consultants. Create a roadmap for your team to achieve Google Cloud certification based on job role. The best approach to evaluate your team's readiness for a new GCP project, incorporating the business goal of cost optimization, is B. Allocate budget for team training. Create a roadmap for your team to achieve Google Cloud certification based on job role. Explanation. 1. Allocate budget for team training. Investing in your team's skills and knowledge of GCP will help reduce future reliance on external consultants, promote internal growth, and ensure a deeper understanding of cost optimization practices. 2. Create a roadmap for Google Cloud certification based on job role. Certification helps formalize your team's expertise and ensures they have the necessary skills to handle the project effectively. It also aligns the skills with the specific roles required for the project, ensuring all aspects of the project are covered. Analysis of other options. A. Allocate budget for team training. Set a deadline for the new GCP project. While team training is important, Simply setting a deadline without a structured skills development plan may lead to rushed or incomplete preparation. It doesn't ensure that the team will be well prepared in terms of knowledge and skills for the project. C. Allocate budget to hire skilled external consultants. Set a deadline for the new GCP project. Hiring external consultants can be useful in the short term, but it doesn't contribute to the long-term growth and self-sufficiency of your team. It may also lead to higher ongoing costs, which conflicts with the goal of cost optimization. D. Allocate budget to hire skilled external consultants. Create a roadmap for your team to achieve Google Cloud certification based on job role. While external consultants can help, focusing on developing your team's internal capabilities is more sustainable and cost-effective in the long run. The combination of hiring consultants and focusing on certifications may add unnecessary complexity and cost. Conclusion. B is the best choice as it focuses on building the team's capabilities in a structured manner, which aligns with the business goal of cost optimization. Question 63. You are designing an application for use only during business hours. For the minimum viable product release, you'd like to use a managed product that automatically scales to zero so you don't incur costs when there is no activity. Which primary compute resource should you choose? A. Cloud Functions. B. Compute Engine. C. Google Kubernetes Engine. D. App Engine Flexible Environment. The best approach to designing an application that scales to zero and minimizes costs when there is no activity is A. Cloud Functions. Key considerations. 1. Serverless nature. Cloud Functions is a fully serverless offering, meaning you don't need to manage infrastructure. This allows the platform to automatically handle scaling and stop resources when not in use. 2. Cost efficiency. Since Cloud Functions scales to zero, you are billed only for the time your function is executing, making it highly cost-effective for workloads that are idle outside business hours. 3. Event-driven model. Cloud Functions is event-driven, meaning it is ideal for handling requests or tasks triggered by specific events, which makes it suitable for business hour workloads. Explanation. 1. Cloud Functions. Cloud Functions is a serverless compute service that automatically scales based on demand and scales down to zero when there is no activity. This means you are only billed for the execution time, making it the most cost-effective choice for applications that are active only during business hours. You won't incur any costs when the function is idle. Analysis of other options. B. Compute Engine. Compute Engine requires you to provision and manage virtual machines, VMs, which do not scale to zero. Even when there is no activity, you'll incur costs for the provisioned VMs. This makes it less suitable for an application that needs to scale down to zero when idle. C. Google Kubernetes Engine. GKE can autoscale the number of nodes and pods, but it doesn't scale to zero without a more complex configuration. You still incur costs for the underlying infrastructure and node instances, even if no pods are running. Therefore, it is not the most cost-efficient option for this use case. D. App Engine Flexible Environment. App Engine Flexible Environment can automatically scale, but it does not scale all the way down to zero. There will still be some costs, such as for idle instances. Although it provides automatic scaling, it's not as cost-efficient as Cloud Functions for applications with no activity during off-hours. Conclusion. A is the best choice because Cloud Functions scales to zero automatically, meaning you will incur no costs when there is no activity, aligning with the goal of minimizing costs during periods of inactivity. Question 64. You are creating an App Engine application that uses Cloud Datastore as its persistence layer. You need to retrieve several root entities for which you have the identifiers. You want to minimize the overhead in operations performed by Cloud Datastore. What should you do? A. Create the key object for each entity and run a batch get operation. B. Create the key object for each entity and run multiple GET operations, one operation for each entity. C. Use the identifiers to create a query filter and run a batch query operation. D. Use the identifiers to create a query filter and run multiple query operations, one operation for each entity. The best approach to retrieving several root entities from Cloud Datastore with minimal overhead is A. Create the key object for each entity and run a batch GET operation. Key considerations. 1. Minimizing overhead. Batch operations are more efficient than multiple individual operations. Using a batch GET operation will reduce the number of network requests made to Datastore, thus minimizing overhead. 2. Efficient retrieval. Cloud Datastore allows retrieving multiple entities by their keys in a single operation, which is faster and more efficient than executing separate GET operations for each entity. 3. Scalability. Batch operations are designed to scale more efficiently in terms of latency and throughput compared to running multiple GET or query operations. Explanation. 1. Create the key object for each entity and run a batch GET operation. This method allows you to fetch multiple entities using their keys in a single call to Cloud Datastore, reducing the operational overhead of multiple network requests. A batch GET operation is specifically designed to minimize the time and resources needed to retrieve several entities at once. Analysis of other options. B. Create the key object for each entity and run multiple GET operations, one operation for each entity. This approach requires multiple calls to Datastore, which increases network overhead and latency. It's less efficient than using a batch GET operation. C. Use the identifiers to create a query filter and run a batch query operation. While querying can be efficient for retrieving entities based on certain criteria, it is not the most efficient method when you already know the identifiers of the entities. Batch GET operations are a better fit for this use case, as they are specifically designed to fetch entities by key. D. Use the identifiers to create a query filter and run multiple query operations, one operation for each entity. This approach also involves multiple network calls and would be less efficient than using a batch GET operation. Query operations are more suitable when you need to retrieve entities based on criteria, not just specific identifiers. Conclusion. A is the best choice as it minimizes overhead by using a batch GET operation to retrieve entities by their keys in a single request. This is the most efficient method for the described use case. Question 65. You need to upload files from your on-premises environment to cloud storage. You want the files to be encrypted on cloud storage using customer-supplied encryption keys. What should you do? A. Supply the encryption key in a .boto configuration file. Use XUtil to upload the files. B. Supply the encryption key using gcloud config. Use XUtil to upload the files to that bucket. C. Use XUtil to upload the files, and use the flag encryption key to supply the encryption key. D. Use XUtil to create a bucket, and use the flag encryption key to supply the encryption key. Use XUtil to upload the files to that bucket. The best approach to upload files from your on-premises environment to cloud storage and ensure the files are encrypted using customer-supplied encryption keys is C. Use XUtil to upload the files, and use the flag encryption key to supply the encryption key. Key considerations. 1. Customer-supplied encryption keys. CSEK Google Cloud allows you to supply your own encryption key for encrypting data at rest. The encryption key flag is specifically used for this purpose with XUtil. 2. Simplicity and efficiency. The XUtil command line tool provides a simple, efficient way to interact with cloud storage. Using the encryption key flag ensures that the files are uploaded with the provided encryption key without needing extra configuration steps. 3. Security. When using customer-supplied encryption keys, it's crucial to ensure proper handling of the keys. The encryption key should be managed securely, and appropriate access controls should be in place to protect the key. Explanation. 1. Use XUtil to upload the files. and use the flag encryption key to supply the encryption key. This is the correct method because it directly provides the encryption key as part of the XUTIL upload command. It allows the files to be encrypted on cloud storage using the key you supply. This approach is simple and directly addresses the need for encryption using a customer-supplied key. Analysis of other options. A. Supply the encryption key in a .boto configuration file. Use XUTIL to upload the files. While you can supply encryption keys using the .boto configuration file, this method is not ideal for temporary or on-the-fly key use. It is more suited for persistent configurations rather than individual file uploads. B. Supply the encryption key using gcloud config. Use XUTIL to upload the files to that bucket. gcloud config does not allow you to directly set customer-supplied encryption keys for file uploads. Encryption keys should be specified with XUTIL through the encryption key flag. D. Use XUTIL to create a bucket, and use the flag encryption key to supply the encryption key. Use XUTIL to upload the files to that bucket. While this approach would work for setting the encryption on the bucket itself, it does not address the file-level encryption requirement. Option C is the more appropriate solution for encrypting the files individually during the upload process. Conclusion. C is the best choice as it directly applies the customer-supplied encryption key during the file upload process, ensuring the files are encrypted as required. Question 66. Your customer wants to capture multiple GBs of aggregate real-time key performance indicators, KPIs, from their game servers running on Google Cloud Platform and monitor the KPIs with low latency. How should they capture the KPIs? A. Store time series data from the game servers in Google Bigtable, and view it using Google Data Studio. B. Output custom metrics to Stackdriver from the game servers, and create a dashboard in Stackdriver Monitoring Console to view them. C. Schedule BigQuery load jobs to ingest analytics files uploaded to cloud storage every 10 minutes, and visualize the results in Google Data Studio. D. Insert the KPIs into Cloud Datastore entities, and run ad hoc analysis and visualizations of them in Cloud.lab. The best approach to capture multiple GBs of aggregate real-time key performance indicators, KPIs, from game servers running on Google Cloud Platform and monitor the KPIs with low latency is B. Output custom metrics to Stackdriver from the game servers, and create a dashboard in Stackdriver Monitoring Console to view them. Key considerations. 1. Real-time monitoring. The primary requirement is real-time monitoring of KPIs with low latency. Stackdriver monitoring, now part of Google Cloud Operations Suite, is designed specifically for real-time monitoring and alerting on custom metrics. 2. Custom metrics. Stackdriver allows you to define custom metrics for monitoring the game servers, which can track KPIs in real time. 3. Visualization. Stackdriver monitoring provides native support for creating dashboards to visualize metrics, making it easy to track the game server's performance and KPIs. Explanation. 1. Output custom metrics to Stackdriver. This option is ideal because Stackdriver monitoring allows for the ingestion of custom metrics from game servers and can be used to monitor KPIs with low latency in real time. 2. Create a dashboard in Stackdriver Monitoring Console. Stackdriver provides an easy-to-use dashboard feature to visualize these custom metrics in real time, providing insight into the performance of the game servers. Analysis of other options. A. Store time series data from the game servers in Google Bigtable, and view it using Google Data Studio. While Google Bigtable is a great option for handling time series data at scale, it is not primarily used for real-time monitoring of metrics. Google Data Studio is more suitable for visualizing data in a more static or batch-oriented manner, not for real-time monitoring. C. Schedule BigQuery load jobs to ingest analytics files uploaded to cloud storage every 10 minutes, and visualize the results in Google Data Studio. This option introduces unnecessary complexity for real-time monitoring, as it relies on batch processing every 10 minutes, which is unsuitable for low-latency, real-time KPI monitoring. It also involves additional steps like file uploads and load jobs, which adds latency. D. Insert the KPIs into Cloud Datastore entities and run ad hoc analysis and visualizations of them in Cloud.lib. Cloud Datastore is not the best choice for high-throughput, real-time metrics collection, and Cloud.lib is more suited for interactive data analysis rather than monitoring and visualizing real-time metrics. This setup would introduce unnecessary latency. Conclusion: B is the best choice as it allows for real-time monitoring of custom KPIs with low latency, which is the primary requirement for the customer. Question 67. You have a Python web application with many dependencies that requires 0.1 CPU cores and 128 megabytes of memory to operate in production. You want to monitor and maximize machine utilization. You also want to reliably deploy new versions of the application. Which set of steps should you take? A. Perform the following. 1. Create a managed instance group with F1 microtype machines. 2. Use a startup script to clone the repository, check out the production branch, install the dependencies, and start the Python app. 3. Restart the instances to automatically deploy new production releases. B. Perform the following. 1. Create a managed instance group with N1 standard 1 type machines. 2. Build a compute engine image from the production branch that contains all of the dependencies and automatically starts the Python app. 3. Rebuild the compute engine image and update the instance template to deploy new production releases. C. Perform the following. 1. Create a Google Kubernetes Engine (GKE) cluster with N1 standard 1 type machines. 2. Build a Docker image from the production branch with all of the dependencies and tag it with the version number. 3. Create a Kubernetes deployment with the image pulpalic set2, if not present, in the staging namespace, and then promote it to the production namespace after testing. D. Perform the following. 1. Create a GKE cluster with N1 standard 4 type machines. 2. Build a Docker image from the master branch with all of the dependencies and tag it with latest. 3. Create a Kubernetes deployment in the default namespace with the image pulpalic set2 always. Restart the pods to automatically deploy new production releases. The best set of steps for monitoring and maximizing machine utilization while reliably deploying new versions of the application is C. Key considerations. 1. Containerization and flexibility. Kubernetes, GKE, provides a flexible, scalable environment for deploying and managing containerized applications. Containerizing your Python app with Docker ensures that all dependencies are included, and the application can be reliably deployed across environments. 2. Version control. Tagging the Docker image with the version number ensures that specific versions of the application can be deployed reliably, making it easier to manage updates and rollbacks. 3. Resource utilization. The N1 standard 1 type machines provide a balanced amount of resources suitable for the app's light requirements, 0.1 CPU and 128 megabytes of memory, maximizing machine utilization. 4. Deployment pipeline. Promoting the application from the staging namespace to production ensures that the app is tested before it is released into production, reducing the risk of deployment issues. Explanation. 1. Create a GKE cluster with N1 standard 1 type machines. GKE allows for the management of containerized applications. Using N1 standard 1 machines aligns with the app's lightweight resource needs and maximizes utilization. 2. Build a Docker image from the production branch with all dependencies. Docker ensures that all dependencies are included, providing consistency across environments and reducing configuration issues. 3. Create a Kubernetes deployment with the image pulpalic set2, if not present. This ensures that Kubernetes pulls the Docker image only if it's not already present on the node, reducing unnecessary downloads and improving deployment speed. Analysis of other options. A. Create a managed instance group with F1 microtype machines. While this option uses lightweight instances, F1 micro it requires manual handling of dependencies and application deployment using startup scripts, which can be error-prone and less scalable. Restarting instances for each release is not ideal for managing production environments. B. Create a managed instance group within one standard one-type machines. While using an image and instance groups can help scale and deploy the application, it lacks the flexibility and automation that Kubernetes provides. Rebuilding images for each release adds complexity and doesn't offer the same level of monitoring and management as Kubernetes. D. Create a GKE cluster within one standard 4-type machines. While GKE is used, the use of N1 standard 4 machines is an over-provisioned solution for an application with light resource requirements. Additionally, using the latest tag for Docker images and the always image policy can lead to unreliable deployments and difficulties in rollback, as it forces Kubernetes to always pull the latest image, even for production deployments. Conclusion: C is the best choice as it combines the flexibility, scalability, and reliability of Kubernetes with the ability to manage containerized applications efficiently while maximizing machine utilization and minimizing downtime during deployments. Question 68. Your company wants to start using Google Cloud resources but wants to retain their on-premises Active Directory domain controller for identity management. What should you do? A. Use the admin directory API to authenticate against the Active Directory domain controller. B. Use Google Cloud Directory Sync to synchronize Active Directory usernames with cloud identities and configure SAML SSO. C. Use Cloud Identity Aware Proxy configured to use the on-premises Active Directory domain controller as an identity provider. D. Use Compute Engine to create an Active Directory AD domain controller that is a replica of the on-premises AD domain controller using Google Cloud Directory Sync. The best solution to integrate Google Cloud resources while retaining the on-premises Active Directory domain controller for identity management is: B. Use Google Cloud Directory Sync to synchronize Active Directory usernames with cloud identities and configure SAML SSO. Key considerations: 1. Hybrid identity management. Google Cloud Directory Sync (GCDS) allows you to synchronize user accounts, groups, and other directory information between your on-premises Active Directory and Google Cloud, ensuring a unified identity management system. 2. Single sign-on. SSO configuring SAM-based single sign-on (SSO) enables users to access Google Cloud resources using their existing Active Directory credentials, improving security and user experience by reducing the need for multiple logins. 3. Retaining on-premises AD. By synchronizing with Active Directory, this solution allows your organization to retain its on-premises identity infrastructure while leveraging the benefits of Google Cloud. 4. Scalability. This solution allows scalability by enabling the synchronization of user data and enabling access to cloud resources with minimal overhead. Explanation: 1. Google Cloud Directory Sync (GCDS) is a tool that allows for synchronization of user information, groups, and other directory data from Active Directory or LDAP to Google Cloud. It ensures that users in the Active Directory have corresponding cloud identities in Google Cloud, making management more efficient. 2. SAML SSO configuration enables your organization to use a single set of credentials for logging into both on-premises and cloud applications. With this setup, users authenticate against Active Directory and access Google Cloud resources seamlessly. Analysis of other options. A. Use the admin directory API to authenticate against the Active Directory domain controller. The admin directory API is primarily used to manage Google Cloud identities, not for authenticating against on-premises Active Directory. It does not provide a direct integration for using Active Directory as the identity provider for Google Cloud resources. C. Use Cloud Identity Aware Proxy configured to use the on-premises Active Directory domain controller as an identity provider, while Identity Aware Proxy (IAP) provides secure access to applications. It typically works with Google Cloud Identity or a third-party identity provider. Configuring it to use on-premises Active Directory directly as an identity provider is not a typical use case, and GCDS with SAML SSO is more appropriate. D. Use Compute Engine to create an Active Directory AD domain controller that is a replica of the on-premises AD domain controller using Google Cloud Directory Sync. While this option involves setting up an AD domain controller on Google Cloud, it requires ongoing management and doesn't fully integrate with Google Cloud Identity and SSO systems as seamlessly as using GCDS with SAML SSO. It also adds unnecessary complexity for synchronizing identities. Conclusion: B is the best choice because it integrates Active Directory with Google Cloud in a way that aligns with hybrid cloud environments, offering seamless user access through SAML SSO and synchronization via Google Cloud Directory Sync. This approach minimizes the need for significant changes to existing identity management while enabling secure, unified access to cloud resources. Question 69. You are running a cluster on Kubernetes Engine, GKE, to serve a web application. Users are reporting that a specific part of the application is not responding anymore. You notice that all pods of your deployment keep restarting after 2 seconds. The application writes logs to standard output. You want to inspect the logs to find the cause of the issue. Which approach can you take? A. Review the Stackdriver logs for each Compute Engine instance that is serving as a node in the cluster. B. Review the Stackdriver logs for the specific GKE container that is serving the unresponsive part of the application. C. Connect the cluster using gcloud credentials and connect to a container in one of the pods to read the logs. D. Review the serial port logs for each Compute Engine instance that is serving as a node in the cluster. The best approach to inspect the logs and find the cause of the issue is B. Review the Stackdriver logs for the specific GKE container that is serving the unresponsive part of the application. Key considerations: 1. GKE and Stackdriver logging. Google Kubernetes Engine, GKE, integrates with Google Cloud's operations suite, including Stackdriver logging, to provide detailed logs for containers running in your cluster. 2. Container-level logs. Since the application writes logs to standard output, reviewing Stackdriver logs for the specific GKE container allows you to directly view logs related to the issue within the container. 3. Pod restarting. If the pods are continuously restarting, the logs may provide critical information about why the container is failing, such as application errors, resource exhaustion, or configuration issues. Explanation: 1. Stackdriver logging provides centralized logging and integrates with Kubernetes clusters. The logs are available for each container, and you can filter the logs by container name to quickly locate issues related to specific parts of the application. 2. Reviewing logs for the container running the unresponsive part of the application will allow you to examine error messages or exceptions that might be causing the pods to restart. Analysis of other options. A. Review the Stackdriver logs for each Compute Engine instance that is serving as a node in the cluster. While this option might give insights into the node-level health, it is unlikely to provide detailed application logs, especially since the application writes to standard output. The issue is more likely related to the container or pod level, not the node level. C. Connect the cluster using gcloud credentials and connect to a container in one of the pods to read the logs. While connecting directly to a pod may allow you to inspect logs using kubectl logs, this requires access to the cluster and might not be as efficient as using Stackdriver, which centralizes and filters logs. It's better to leverage Stackdriver for a more scalable approach. D. Review the serial port logs for each Compute Engine instance that is serving as a node in the cluster. Serial port logs primarily capture information related to the boot process and system-level issues on the Compute Engine instances. These logs are not ideal for debugging application-specific issues, especially if the problem lies within the application code running inside containers. Conclusion: B is the best option because Stackdriver logs for the specific GKE container provide the most relevant information for diagnosing issues with the unresponsive part of the application, especially if the application writes to standard output. This method is efficient, centralized, and designed to work with Kubernetes workloads. Question 70. You are using a single Cloud SQL instance to serve your application from a specific zone. You want to introduce high availability. What should you do? A. Create a read replica instance in a different region. B. Create a failover replica instance in a different region. C. Create a read replica instance in the same region, but in a different zone. D. Create a failover replica instance in the same region, but in a different zone. The best approach to introduce high availability for your Cloud SQL instance is D. Create a failover replica instance in the same region, but in a different zone. Key considerations. 1. High availability. For high availability, the solution should ensure that if the primary instance fails, the failover replica can automatically take over without causing significant downtime. 2. Failover mechanism. Cloud SQL provides automated failover capabilities with failover replicas. These replicas are designed to be automatically promoted to primary in the event of failure. 3. Regional redundancy. Placing the failover replica in the same region but a different zone ensures low latency failover without the complexity and increased latency that comes with multi-region configurations. Explanation. 1. Failover replica. A failover replica in the same region but in a different zone ensures that there is no single point of failure. Cloud SQL automatically handles the failover process, promoting the replica to the primary instance if the original instance becomes unavailable. This approach minimizes latency and avoids the complexities of multi-region setups. 2. Zones in the same region. Using different zones within the same region provides redundancy without significantly increasing the latency, as the communication between zones within the same region is much faster compared to communication between regions. Analysis of other options. A. Create a read replica instance in a different region. While creating a read replica in another region can improve data redundancy and provide a backup, it does not provide automatic failover, and there will be higher latency and potentially more cost for cross-region replication. B. Create a failover replica instance in a different region. Creating a failover replica in a different region increases complexity, potential latency, and cost. It is more appropriate for disaster recovery scenarios, not for high availability, as the failover process will have more overhead due to the geographical distance. C. Create a read replica instance in the same region, but in a different zone. A read replica in a different zone can improve read performance and provide some redundancy, but it will not automatically promote the replica in case of failure. It would require manual intervention or custom automation to promote the replica, so it does not meet the high availability requirement. Conclusion. D is the best option because it ensures high availability with automatic failover, is easy to manage, and minimizes latency by keeping the failover replica in the same region but a different zone.